what we were saying was that the cells that we were recording from were cholineceptive, and that they were having this innervation from the basal forebrain. And this fits with the Shute and Lewis sort of activating sort of idea. So that although you've got quite stained cells, if you look at the cortex, you saw stained cells. They were not cholinergic, they were cholineceptive. And the source of those cholinergic fibers were way down in the basal forebrain. The thing about the transmitters in the cortex is that the cholinergic system is a sort of modulatory system, and that the main transmitters are not acetylcholine. The main transmitters are the amino acids, which I was not involved with. So that what we found was that there were these slow acetylcholine responses. Acetylcholine responses are slow and different from the main transmissions. So it's more of a modulatory system. These cholineceptive responses were muscarinic because although I say not much was known about the central nervous system, the nicotinic receptors had been shown in the Renshaw cells in the spinal cord, but our responses were slow, they were muscarinic, they definitely weren't nicotinic. I mean, I think everyone remained cautious about these things, but gradually, things built up to the extent that there seemed to be a body of evidence for it, for the existence of cholinergic synapses in the CNS. Because we were interested in where these fibers we found were actually coming from, we were interested in the developmental side of things, and so we looked at fetal cats as well. And one of the things that we found, which was interesting, was that there seemed to be a change in specificity during development, and the very young fetuses, the enzyme seemed only to be butyryl or pseudocholinesterase, and then cells which had butyryl or pseudocholinesterase then seemed to develop acetylcholinesterase, but this was something that we didn't actually ever follow up. Well, there are places where there's acetylcholinesterase that obviously aren't involved in transmission. Just as in the human primate placenta, there's choline acetyltransferase, which is obviously not involved in transmission. And I was rather fascinated with what acetylcholinesterase might be doing, say, during development, that you get some cells some neurons during development which have acetylcholinesterase, and then it disappears. And in, for instance, the cerebellum, in the Purkinje cells of the cerebellum, if you make lesions in the fibers innervating the cells, acetylcholinesterase suddenly reappears there. It's been there during development, it then disappears, but it comes back again. And this makes one wonder whether it has some kind of sort of metabolic effect. And there are various places where you get it and it disappears again, and particularly in development. And to me, it's a bit of a mystery what it's doing.